Welcome to learning decision trees and random forests in Python. In this lesson, we will discover how decision trees and random forests can help computers make choices based on data. We will use simple examples and a real-world dataset to help you understand. Let us begin our journey into machine learning. Running the cell now. We will first make sure we will not see extra warnings as we work. We import the warnings library so we can control warning messages. This tells Python to not show most warning pop-ups. Now our notebook looks cleaner while we learn. Running the cell now. Now try running other code cells without worrying about extra warning messages. What are decision trees? A decision tree is a machine learning method that sorts data by asking a series of questions. It looks like a flowchart with branches. You can use it for many things, finding if an email is spam, deciding if someone survived the Titanic, and more. Running the cell now. Let us begin coding by creating a simple variable. We make a variable called tree and set it to a short description. We are saving a definition in a variable. We print out the value of our variable to see what is inside. Running the cell now. What other objects in life could be described as decision trees? Think of something and try to put it in a variable too. Let us look at a real dataset, the Titanic. We will use data about Titanic passengers to predict survival. First, let us download the data with pandas, a Python data library. Running the cell now. Let us bring in our Titanic data using pandas. We import pandas, which helps us work with tables. We set the URL to the Titanic data online. We read the CSV file into a table called df. Shape tells us how many rows and columns. Head shows us the first few rows so we get a feel for the data. Running the cell now. Scroll and look at these columns. Can you guess what some of them mean? Try reading a column name out loud. Now let us see how many people survived and how many did not. We look at the survived column. Value_count shows how many times each value appears. Running the cell now. Notice how many did and did not survive. Class imbalance makes predictions harder. Before we build a model, let us get our data ready for training. We will use simple features, passenger class, sex, age, and fare. We turn sex into numbers because computers learn from numbers. We fill missing ages with the middle value so nothing is lost. X is our input data, Y is who survived. We split our data so we can train and test. Here we see how many examples are in each part. Running the cell now. If you were a passenger, how would each of these features affect your survival? Think about it. Building our first decision tree. We will use scikit-learn to build a simple decision tree classifier. Running the cell now. Now let us create and teach a decision tree using our training data. We bring in decision tree classifier from scikit-learn. We make a new tree object and set random_state so results are the same. Fit tells the tree to learn the rules from training data. Now our decision tree is trained and ready. Running the cell now. Now the tree is trained. Try changing random_state and see if you get different results. Let us see what our tree thinks about the test data. We predict who survived in the test set. Now we print the first 10 predictions. Running the cell now. What do ones and zeros mean here? 1 means survived, 0 means did not. It is time to check how well our tree learned from data. We import accuracy_score to measure how often our predictions are correct. We compare what the model said to real outcomes. Then we print accuracy as a %. Running the cell now. A good score means our tree learned something useful. Try it now. What are random forests? A random forest is a group of many decision trees. Each tree gets a different piece of data and makes its own prediction. The forest votes and the most common answer wins. Running the cell now. Let us try a random forest and see if many trees together do a better job. We bring in random forest classifier from scikit-learn. We create a forest with 100 trees for variety. We train the forest just like the tree. Then we get predictions from the forest. Here we print out the first 10 results. Running the cell now. Do you think a group of trees would do better than one tree? Let us see. We will see if our random forest is more accurate than our single tree. We use accuracy_score again to check the forest. We compare and print the forest accuracy. Running the cell now. Did your forest score go up? Try changing n_estimators to see what happens. Let us look at what our random forest thinks is important. We use the feature_importances_ property from our forest. This tells us which columns were most useful for decision making. We use matplotlib to make a simple bar chart. The features array has our column names. We draw bars to show importance. The chart gets a clear title. We label the y-axis as importance. We label the x-axis as feature. Now we show the chart. Running the cell now. Looking at the chart, which feature do you think has the biggest effect on survival? Let us make our own guess for a Titanic passenger. Try entering your values. We ask you to type in a passenger class, 1, 2, or 3. Next you pick male or female. You get to enter the age you want. Then you enter a price for the ticket. We translate the text version of sex into a number for the model. We make a list of all your choices. The forest will predict your chance of survival. If the output is 1, the model thinks you survived. The computer prints out survived for you. If not, it says did not survive. Running the cell now. What combination did you try? Keep changing your values and watch the prediction change. If you like this interactive part, please subscribe for more Python lessons. Want to know how well your model generalizes? Let us try the out-of-bag, or OOB, score. We build a new random forest with out-of-bag scoring turned on. The forest uses some data for training and the rest for testing itself. Fit makes the model learn, while also figuring out OOB accuracy. We look at the OOB score to see how our model might do on new data. Running the cell now. Try changing the number of estimators and see how it affects your OOB score. Beginner tip: missing values can cause model errors. Let us see if any are left. We use NumPy and pandas to check for missing values in our features. np.any lets us know if any data is missing or blank. We print the answer as yes or no. Running the cell now. Always check for missing values before modeling. Try looking at another dataset too. You can get more details on your predictions with a classification report. We import classification_report from scikit-learn. The report tells us about precision, recall, and F1 score for each class. Now you can see which kind of error happens most. Running the cell now. Let us explore these terms. Precision means correct positive guesses, recall means finding everyone who survived. Tip: setting random_state ensures others can get the same results as you. We train 2 decision trees with different random states. The numbers control how the splitting happens. Results may change if you pick a different seed. Printing the first 5 predictions for both models shows if they match. Running the cell now. Try changing random_state and see if you get the same or different results. This is a great way to learn about reproducibility. Challenge: can you change the model to use a different feature? Try swapping out a feature or adding one more column. What happens to your model's predictions? Running the cell now. Recap. You learned to build decision trees and random forests. You used them to predict Titanic survival. Changing features and model settings helped you improve results. You saw how data shape, accuracy, and feature importance work together. Keep practicing and try your own datasets. Running the cell now. Thanks for learning with us. If you enjoyed this, please like, comment, and subscribe to our YouTube channel for more beginner-friendly Python tutorials. Happy coding! Running the cell now.